Here's one more way to solve systems of equations. And what this is going to involve is elimination or addition. So again, one more option, and sometimes this may be the easiest way to do these problems. So let me talk about the term elimination for this process of solving the systems. Elimination, or a definition or explanation, is to cause a variable to disappear by adding two or more mathematical equations. So that's where I put the addition, because you're going to add two equations. And by adding them, we're going to cause a variable to disappear. And you'll see this happen as I go through the examples. But that's just a quick overview of what we're going to be doing. Before I begin an example, I want to make sure we remember additive inverse. 3 plus negative 3 equals 0. That's an additive inverse. Just as with variables, x plus negative x equals 0. Important concept to keep in mind when we go to do this problem. So, here's an example. This is a system. X plus y equals 5. 3x minus y equals 7. That's the system I want to talk about. Add the two equations. So, I put the plus sign there. It helps me remember. Everything's lined up real nice here. X plus 3x is 4x, so we're adding like terms. Y plus negative y equals 0. That's my additive inverse. That's where that review here is really important. And 5 plus 7 is 12. So adding the two equations, one variable is eliminated. 4x equals 12, x equals 3. Just as in all the other processes, once we found one variable, we're going to put it into one of the equations. If x is 3, 3 plus y equals 5. And you can see that the ordered pair solution here is 3, 2. Here's another example. So here's our system, two equations. Again, the examples I'm giving you right now, the x's are lined up, the y's are lined up, equal sign, and constants. So that's important. We're going to add vertically. Again, I like to put in this plus sign to help me remember that I'm adding. Negative 4x plus 4x is 0. That's the additive inverse. Negative y plus 3y is a positive 2y. And negative 6 plus 18 is 12. Divide by 2, you get y is 6. And again, to find that value for x, we're going to take this 6. I'm going to put it right back up into here, which is one of the first original equations, and do the math, and I get x is negative 3. So, again, always express your answer as an ordered pair. So the answer to this one would be negative 3, and y is 6. So that's the one solution, the one point that would solve both of these equations. This example, again, that I chose for you to look at, the x's are lined up, the y's are lined up, equals and constants, but there's a difference. When we add vertically, a variable is not eliminated. 2 plus x, negative 3 plus 4. So we have to create an additive inverse. Now to create one, you will have to look, do we want to eliminate the x's or the y's? And I chose the x. So I have to create an additive inverse here. So if this is positive 2, the additive inverse is negative 2. So I'm going to multiply the entire equation by negative 2. That means I'm going to multiply the x, the negative 4y, and the 1. So multiply the entire equation. When I do that, I take my first equation, leave it as it is, and I'm going to take this one. Negative 2 times x is negative 2x. Negative 2 times that, watch your signs, makes a positive 8y. And negative 2 times 1 is negative 2. I have now created the additive inverse. That was the key to that step. That makes 0, negative 3 plus 8 is 5, and you add here is 10, y is 2. Again, take that value, put it back up into either equation, find the x. Solution is 9, 2. This is another example. Again, variables are lined up, equal sign lined up, but 3 and 5 are not additive inverses, and 5 and 2 are not. So again, we have to create. This one, we have to decide. The least common multiple of 3 and 5 is 15, and the least common multiple of 5 and 2 is 10. We have to choose one of those. I decided to choose the x. So I'm looking for 15. So if this least common multiple is 15, I would have to multiply this by 5. And there I have that. This equation is going to get multiplied by 5. To make this a 15, I'm going to have to multiply by 3. Because then you can see 5 times 3 is 15, 3 times 5 is 15. But it needs to be an additive inverse, so I'm going to make this one negative. Because we're going to need opposite signs. So 5 times 3x is 15x. 5 times that is negative 25y. 5 times that is 35. This is the key. Negative 3 times 5x is negative 15x. That's what we wanted. Negative 3 times negative 2 is plus 6y. And negative 3 times negative 1 is a positive 3. This is the key. This is what we're working for there. Additive inverse. So those are the new equations. So to continue that problem, I rewrote that for you, and we're right back to where we were. We're going to add vertically. This is the additive inverse that creates a 0. This gives us negative 19y, adding here, and again, I'm going to put that plus sign in there. Helps me out there. Divide by negative 19, you get y is negative 2. And again, to find your x value, substitute y equals negative 2 into one of the original equations. It does not matter which one. The original equations as opposed to these new equations. So going back 2 boards ago or so, our original equation was 3x minus 5y equals 7. So I put in the negative 2 right there for that y. So right there it is, and here it is. Do the math, you get x equals negative 1. So again, always, so we have the answer. It will be x is negative 1 and y is negative 2. And that would be your solution for that system.